Let's read the problem statement. Given an array of birds citing where every elements represent a bird type ID. Okay, so the bird is represented with their IDs like 1, 2, 3, 4 like this, and determine determine the ID of most frequently cited type. It means we have to find out which bird cited more frequently. Suppose there are more than one bird type who are cited frequently. In that case, we have to return the smallest ID. So one example is given here, like 1, 2, 3, 4. So these are the uh, ID of the bird 1, 2, 3, and 4. There are two each of type 1 and 2, and one sighting of type 3. So pick the lower of the two types seen twice. Okay, so our task is to find out which bird is sighting more frequently on that. Function description: complete the migratory bird function in the editor. Migratory birds has following parameters, like one array is given in the function as an argument that represents the types of the bird cited, and we have to return the lowest type ID of the most frequently cited bird. This is the output that we have to return. If we are talking about the input and output format, you can see here the first line contains an integer size. The size of the second line, the first line contains an integer, that is the size. The second line describes as space separated integers, that is representing the type number of the birds cited on the that site. And output is the lowest type ID of the most frequently cited bird. Okay. If you're talking about the constants, so here we can see the ID must be between 1 to 50. Means we cannot have more than 50 IDs. And number of birds, if you're talking about, that is 1 to 250. Okay. So this is the basically constraint that is given here. If we talk about the sample input and output, you can see here 6 is the input, that is representing the number of birds. And in the next line, we are having 6 space separated integers representing the IDs of the bird. Okay, like 1, 4, 4, 4, 5, 3. So this is bird 1, type 1, type 4, type 4, type 4, type 5, and type 3. These are the bird type, or we can say that the ID. Okay, so our task is to find out which bird cited more frequently. So if we see, we can easily find out type 4 is cited more frequently. That's why the ID of that bird is returned here, that is 4. Okay, so here explanation is given: type 1, 1 bird, type 2, 0, type 3, 1, type 4, 3, and type 5, 1. So if we find out the more frequently cited word, that is type 3, that is type 4. Type 4 cited 3 times, that is given in the sample input. Okay, type 4 cited 3 times. So like this, we have to find out the result. So how can we solve this problem? So let's begin with the algorithm. To solve this problem, algorithm of this program can be derived as we'll start. In the first step, we have to create a frequency array with initial value 0. So what we'll do, we'll just create one frequency array that is of the size depending on the maximum value given in the bird type. Okay, so if there is you can say 5 is the maximum bird ID type, so we'll create one frequency array of size 5. Basically we have to create one more because we are starting from 0. So 0, 1, 2, 3, 4 and 5. So basically the index of the frequency array, this is frequency array, we are saying that FR. In the frequency array, the indices are representing the bird ID or bird type. And in initial we will have 0, 0, 0 in these. After that, what we'll do, we'll just repeat for each bird that given in the list, in the array that is given by user. Suppose if we take the previous example, in the previous example we had you can easily see in the previous one we had 1 4 4 5 3. So we'll first create that 1 4 4 5 3. So let's create 1 4 4 4 5 3. So this is the original array that is given representing the bird sighted. Okay, so what we'll do, we'll start encountering one by one. Suppose the first element is 1, so we'll move to the 1 index in the frequency array and we'll increase that value by 1. After that, move forward. Here we have 4. Again, we will move to the 4 index in the frequency array and increase the value by 1. Again, we have encountered 4. Again, go to the 4 index in the frequency array and increase by 1. Again, we have 4. So what we'll do, every time we encounter the value, we will go to that index and increase that value by 1. After that, we have encountered 5 and we will move to the 5 index and increase the value by 1. In the last, we have 3, we'll move to the 3 index and increase the value by 1. So after that, you can see after encountering all the values that is given in the ARR, we have final status as 0, 1, 0, 1, 3 and 1. Now what we'll do, we'll just scan this frequency array and try to find out the maximum value. So here we have maximum value 3 and that is of type 4. So we'll just return 4 as the result. So what we'll do, we'll scan the frequency array and whenever we encountered the maximum value of any index, we just return that index and that index is our desired output.
So here we have migratory bird on Hackerrank platform. In the problem statement, given an array of bird sightings where every element represents a bird type ID. Determine the ID of the most frequently cited type. Okay. So we have already seen the discussion and the algorithm also. Now here we will write the code. So just move to the coding part. We will not write entire code. What we'll do, we'll just complete migratory bird uh, function. So first of all, let us see what are the parameters given. So in the comment section, you can see complete the migratory bird function below. The function is expected to return an integer. It means in this function, we will return one integer value that is representing the bird type or bird ID. The function accepts integer array as a parameter. So this is the migratory bird function. In this, we can see this is the array. Basically, this is array called passed by call by reference. So it is representing the address of the array. And ARR underscore count is representing the size of this array. Okay, so we have array element along with the size of that array. So we'll write our code in this function only. And in real time, this is basically the technique used in the competitive examination, because at that time we might not have much time to write entire code. That will be very time-taking process. So first of all, according to the technique that we have used, first of all we have to create one frequency array of size n plus 1. So here in the problem, it is already mentioned that the maximum size is maximum bird ID type is 5. So we'll create one frequency array of size 6. So let us write the code int f. Suppose that is the frequency array and of size 6. And what will be the initial value in the frequency array? The initial value will be 0. And along with that, we'll create one extra variable I for that will be used in the loop as an iterator. Okay. So here we have one frequency array of size 6 and one variable I that will be used as iterator. Okay. Now next task is what we'll do. We'll run a loop for I equals to 0 and I equals to 0, I less than ARR underscore count. Why we are taking ARR underscore count? Because it is already given in the function as parameter. So we'll use that same variable here. That is representing the size of the array. So we have to iterate this loop for each element given in this ARR array. Okay. After that, I plus plus. And now what we'll do for each element or bird ID that we are reading in the ARR, we will move on that index in the frequency array and update the status by 1 or increase the status by 1. So for that, we will use soft form. So what we'll do in the F array, at what location? The location will be ARR I. So in the F array, that is frequency array, at index ARRI, we will update the value by 1. We will increase that value by 1. So we will just write plus plus, increment operator. So this is the short notation that we have used. By this, on every index that is given in the, for every ID that is given in the ARR array, we will increase the value in the frequency array. After writing this, after executing this loop, our frequency array will have the count of each bird ID type. And now our task is to find out the maximum value of at particular index, and we will return that index. So for that, we will declare one variable like max, and the initial value of that max will be 0. Okay. And now we will run a loop for I equals to 1, I less or equal to 5. Why we are running 5? Because it is already given in the problem that maximum ID is 5. So from 1 to 5. So we will scan from 1 to 5 and try to find out the maximum value, uh, the index of the maximum value, and we'll return that index. So max will have the index on which the value is maximum in this frequency array. Okay. So what we'll do, so if f of I is greater than f of max, what we are saying? We are saying that the max is having the index of the array at which location the value is maximum. We are supposed to accept. So if any value we are encountering that is greater than the value at max, so we'll update our max. Simple. So what we'll do, we'll just what we'll do, max equals to 5. So after writing this, our max will have the index at which the value is maximum. It means index is in the frequency array, index is representing the bird ID, and we need that. So what we'll do, we'll just return max coming out from this loop. So whenever we'll come out from this loop, we'll return max. So whatever code we have written is in this migratory word function. First step, we have just declared one frequency array of size 6 and initialized it with value 0. It means initial value at 0. And we have declared one variable I that will be used for the iterator in the for loop. After that, in the first step, you can see we have run a for loop for ARR underscore count times because this is the size of the given array. And for each element in the ARRI, for each element in the ARR array, we have updated the value at the same index in the frequency array app. After that, we have just declared a variable max as 0, and we are trying to find out the index at which the value is maximum in the frequency array, and then return that max. Okay, so this is the complete code. Let us uh, run this code. So we can see sample test cases are passed. Now let us submit the code. So yeah, you can see we have passed all test cases. It means our program is correct. And this is the optimized solution, which solves this problem in order of n time. If we use brute force approach, in which we just take the one ID and compare it with other IDs in the given array, it will take order of n squared time. So that is the brute force approach. This is taking order of n squared. So this one is the optimized solution for migratory birds. Thank you.